Okay girls, prepare yourself for a bit of a whirlwind ride here through the recursion and financial modelling SAC, and these are the solutions. Okay, so feel free to jump around and find the questions that you're after here, but I'm going to be working this from question 1 all the way through to question 11, I think it was. I'll be giving a few tips along the way and a few sort of common errors, I suppose, and I'll give some anecdotal feedback about questions that were done well and not so well. So yeah, hope you get something out of it. If anything, it's just you know, how what we were looking for in the particular questions that that you got wrong. Okay, so here we go. All right, so here we are, question 1. So what we had here is the recurrence relation with the initial value 12, and the next term in the sequence is generated by adding 5 to the previous term. So what I did was wrote the first 5 terms, okay, as follows. Okay, so let's run the sequence on our calculator, and our initial value is 12, and we're adding 5 to each term. So the second term is 17, the third term must have been 22. Right, how many terms in the sequence defined by the recurrence relation will have a value less than 47? So actually a lot of students got this one wrong. Okay, so let's keep running the sequence and see what happens. So back to there. So back to my calculator, and we've got 27, 32, 37, 42, 47. So we're looking for less than 47, so this one won't be included. So we're going 42, 37, 32, 27, 17, and actually the initial value is also included. Okay, so the thing is with this one here is this is the first term in the sequence, the initial value, second, third, fourth, the fifth, then we had what was it, 37, 42, the sixth term, and the seventh term. So there's actually 7 terms in the sequence. Alright, so those who know me well will know that I don't have great handwriting, so that is a true story, that. And I'm reviewing my notes and find that there are instances where I cannot read what I have written. So write the appropriate value in the box if Mr. Miller used the recurrence relation below to generate this sequence here. Okay, so we had a start value of 10, and what we're looking for is it's 1.5 times the previous term, subtracting a certain amount. Okay, alright, so the way I would do this question here is I would go, alright, initial value is 10, we're going multiply it by 1.5, which is 15, and what must have happened then is that I subtracted 3 to get 12. So I'm suspecting that it will be a 3 in the box. Right, and then what I'm going to do is just try it out. Okay, so I keep clicking on this. Back to my calculator, I'm putting 10 as my initial value, times 1.5, and subtract 3, generates 12. The next value should be 15, and it is. The next value should be 19.5, and we've got it. Okay, that was done well, that question. This one here also was, students struggled with this one. Okay, so this question here. So write the appropriate value in the box if Mr. Miller knows that the third term, H3 of the recurrence relation is below is equal to 171. Okay, so what we need to know for this one here is that we know that, what is it, T or H rather, H3 is 171. So basically we need to find H2, H1, and then the initial value. Okay? Alright, so how do we do that? There's a few different ways of doing this. So essentially what you could do is do this recurrence relation in reverse. So what you were doing was multiplying by 4 and adding 1 and subtracting 1. You can add 1 and divide by 4. Okay, so what we're going to do to find H2 is add 1 plus 1 and get the result, and then divide by 4, which was 43. So H2 must have been 43, and we're just going to repeat that process. Okay, so we're going to add 1 and divide by 4. That was 11, and then we add 11 plus 1 is 12, divide by 2, divide 11 plus 1, divide by 4. What am I doing? 11 plus 1, divide by 4 is 3. So this value here must have been 3, okay? And then what I would do after I thought that that was 3 is I'd try it out again. So my initial value is 3. If I times by 4 and subtract 1, I get 11. That's the second term in the sequence. The third term in the sequence, the fourth term, is, or H3 is 171. So definitely got that one right. So the common responses to this one here, a lot of students wrote 11. A number of students wrote 43 as well. Okay, so it was rare to see 3 as the answer to that. That was a little bit of a different question there, so hadn't really seen that in the book, but it's just an application of what you know about equations, and again to prepare you what VCAR like to do to you in exams, which is to throw you something and get you to think. Alright, so let's get on to this question here. These first two parts were done very, very well. Alright, so what we've got is Bank of Miller offering 5% per annum simple interest. So make sure you underline those key words. Bank of Gabriel is offering a rate of 4.5% per annum compounding annually. Okay, remember we like the annual compounds because it means there's not a lot we have to do to that rate. Okay, so complete the recurrence relation for Bank of Miller by adding the appropriate value in the box. So our initial value is 5,000. Next term in the sequence is generated by adding an amount to the previous term. Okay. Now we know that the Colester student's investing $5,000, so we're going to do 5% of 5,000. That's 250. So 250 is being added each time. Alright, for this one here, it's compounding annually, so what we're going to do is do 4.5 divided by 100 plus 1, and that value there is 1.045. Some people, because you got in the habit of splitting the compound, but a lot of people divided by 12. Not a lot, but there was a handful of you who did that. Okay, so just make sure you read the keywords in the question. Don't always assume that the compound is monthly. Alright, so what you needed to do was then apply the recurrence relations. So Bank of Miller, we wanted to track the end of first year, second year and third year investment values. So let's stick 5,000 and add 250. So it's 5250. The next one would have been 5,500 and 5,750. Okay, so then with Ms. Gabriel's account, we got that. We're multiplying by 1.045. So the first value was 5225, and then it was 54. So we're just going to write both of those down. 5460.13 and 5705.83. Now this is where a lot of you lost your first mark for a rounding error. So this question here says to the nearest cent, and a lot of people think that the nearest cent is to one decimal place. This is a cent here, but actually the nearest cent just is another way of saying round to 2 decimal places. Now the next thing you'll ask is, why didn't I say that? And that's because, again, VCAR says this a lot, okay, to the nearest cent. So you need to be familiar with this, okay? So if you didn't round that to 2 decimal places, you certainly lost a mark for rounding error. So how much more interest will the Colester student earn at the end of 3 years if she invests her money with Bank of Miller? Okay, so Bank of Miller is there. So what we're going to do is remove Bank of Gabriel's amount from the Bank of Miller, and what's left over will be how much more she earns. 5750 take away 5705.983 rather, and it was $44.17. Not many people showed working there. A lot of you just wrote 4417. Again, it's a 1 mark question. That's fine. But get in the habit of putting some working out. It's just, a good way to communicate your thoughts. Okay. Another error on this question was a lot of people wrote 750 as an answer. You just thought, how much interest will the Colesta student earn at the end of 3 years if she invests her money with Bank of Miller? Okay. But the key word there was more. Okay. All right, how long will a Colesta student need to invest her money before the Bank of Gabriel or Bank of Gabriel will earn more interest? Okay, now common answer was 4 on this one. Okay, the correct answer is 6, but a common answer was 4. Because a lot of people thought they just did one more increment of the Bank of Gabriel's. So what you did was hit enter one more time on this recurrence relation. Let's just start it back up again. So 5,000 multiplied by 1.045, 2, 3, and then 4. And what you assumed is that 5,962.59 was obviously more than 5,750. But what you've got to remember is that the Bank of Miller also increments at the same time. Okay, and so the next value here would have been 6,000 as opposed to 5,962.59. So it's still better to invest with me, okay? And in fact, what you'll find is that if you run this for, I think it's 2 more increments, that's the first time Bank of Gabriel's that investment option will take over as the better option. So the correct answer here was 6 years, okay, at the end of 6 years. All right. Ms. Gabriel purchased her car for $38,900. It'll depreciate by 6% of its purchase price each year using flat rate depreciation. So again, you need to be familiar with what flat rate is. Flat rate basically means it goes down by the same amount each year. Okay, so I've told you that the annual depreciation is this, and I want you to show me. Well, simple. All you do is you know that it's depreciating by 6%, so you needed to do something like this. 6 over 100 times 38,900 will equal 2334, and that's all you needed to do. Alright, let Vn be the value of the car n years after it's purchased. Write down a recurrence relation. Okay, now remember, a recurrence relation has 2 parts. Okay, so the first thing, and this is really important, you must put the initial value first. So a few of you lost marks for doing it the other way around. So the initial value V0 must be defined first. That's the purchase price of the car, 38,900, and then Vn plus 1 equals Vn take away 2334 is the recurrence relation. The next term can be calculated by subtracting 2,334 from the previous term. So it needed both of those things to get the 2 marks for that. If you got that one right, that one wrong, I gave you 1 mark. If you got them out of order, I gave you 1 mark and deducted 1 mark for having them out of order. Okay? Now, you might think, oh, that's a little bit fussy, like what's the difference? Again, there's a bulletin recently from VCAR that actually stated that the recurrence relations need to be in this particular order for the exams. So again, what we hope is that by teaching you this now in a SAC, if you lost a mark for that, don't do it again, and you won't lose a mark in the exam, which will be a lot more valuable then than it is in a SAC. Alright, so this is the other one here. Use recursion to write down calculations that show the value of the car after 3 years is this value here. So you had to use recursion. Okay, so this is a non-negotiable here. Alright, so a lot of you actually used a rule and worked out what 3 lots of 2,334 was, removed it from there, and it came up as that value. But it needed to be done recursively. Okay, so what we know is that V0 equals 38,900. We know that V1 can be calculated by doing 38,900 take away 2,334, and that will be equal to that amount there. and then V2 equals 36566, take away 2334. So basically you understand that what you had to do was actually do 3 lots, or show 3 lots of subtractions. And then V3, which is what I'm after, is 34232, take away 2334, and this should show that. And there it is. Alright, so those of you who use the rule, or those of you who just listed the value of V1, V2, V3, I didn't give any marks for that. Okay, it had to be recursion, and you had to write down calculations. Okay, so that was the important part there. So I was looking for these subtractions here to give the marks for that. Alright, so for this one here, Ms. Gabriel, she wrote a rule for this, but unfortunately she did get it wrong. So I've told you that the rule is written incorrectly. By using it to find the value of the car after 3 years. Okay, so what we're looking for is V3, so 2334 multiplied by 3, take away 38900. And we came up with, so V3, according to this rule, equals negative 31898. Now we know that it's positive, okay, so therefore wrong because neg. Alright, now if you just listed that line there, that was fine, gave you a mark for it. But girls, make sure you put a statement in there. It's really good to sort of then go, alright, you know, I mean, show that, you know, that she did it incorrectly. Well, why is that incorrect? What's wrong with that? Make sure you have a statement. Okay. State the correct rule that will calculate the value of the car after n years. So we simply have to swap that around. Well, not quite swap, but it's Vn equals 38900, take away 2334. N was the correct rule. Alright, if the car had depreciated by 6% each year using reducing balance depreciation method, calculate the difference in the value of the car between the reducing balance and the flat rate. Alright, so look, we already know that the flat rate was 31898, so we've been given that already. Okay, so let's work out the reducing balance, and we're going to do that recursively. Okay, so again, what we're going to do is put the purchase price in, which was $38,900, and what we're going to do is, we know that it depreciates by 6% each year. Okay, alright, so actually let's work out the value that we're going to multiply by. Okay, so the way we do that is we do, how do we do it? We do 1 take away, no, let's not do that. Let's do 100 take away 6 is 94. Okay, and then we're going to divide that by 100. Alright, just a little mental blank there. Yep, so what we did was we did 100 take away 6 is 94, and then we're going to convert that to a decimal, so multiply by 100, and I want to force the decimal, so I'm going to put 100 point, okay, which is 0.94. Alright, so again, let's put purchase price of the car and multiply by 0.94, and we're doing that after 3 years. So there's the first year depreciation value, second year depreciation value, and third year depreciation value. So that is 32309.72. Okay, now again, I know it doesn't say 2 decimal places, but we're dealing with financial figures, girls, so you need to assume that it's to 2 decimal places. Okay, so those of you who rounded that, or just left it as 32308, that's a rounding error. Alright, so a lot of you just found the reducing balance value of the car after 3 years. what you needed to do now was go 32307.72, take away 31898, and from memory I think you get, I can't remember, let's work it out. Take away 31898, $411.72. Alright, under the reducing balance conditions, how long does it take for Ms. Garibill's car to have a value under 30,000? So let's go back to the recurrence relation, 38,900, multiplying by 0.94, first year value, second year value, third year value, fourth year value, fifth year value. So it takes 5 years. Okay, this was a question that a lot of students found difficult. A former Colester student wishes to establish a scholarship fund to support students at Colester. She plans to invest $50,000 in a term deposit that pays 6.5% per annum annual interest. If the interest that is calculated and paid monthly is the amount for the scholarship, how much money will be available each year to be awarded? Alright, so what we're going to do is basically, to do this, we're going to do 6.5 over 100 multiplied by $50,000, and I think from memory that's $3,250. Okay, so that one there wasn't too bad, and a lot of girls got that one right. This one was a struggle. Okay, so the student actually wants to have $4,000 each year. How much money will she have to invest to the nearest dollar? So this is telling us about some rounding here. At 6.5% per annum to earn the required rate each year. So it's 6.5 over 100 times an unknown amount to give us $4,000. Okay, so we're looking for X here, which we're going to do on the calculator via a solve. So we're going to go solve 6.5 over 100 multiplied by X equals 4,000, comma X, let's forget that. And it's saying that the answer is 61538.46. We want to round this to the nearest dollar. So what a lot of you did was said that that is 61538. But in fact, we need to be careful because this rounding to the nearest dollar is not going to give us the $4,000. In fact, it's going to be less. Okay, so your actual answer actually needed to, instead of that, be 61539 to be actually correct. Okay, so again, it's just about thinking about your answer there, girls, and making sure that that will give you the 4,000. Okay, if you round it, so she needs to get the amount, $4,000. So how much to the nearest dollar will get her $4,000? It's actually this amount here. So I didn't penalise this, or I didn't give you a wrong answer. Those of you who committed this one, you got a rounding error. If you'd already made a rounding error, that means you'll get the marks for this question anyway. Okay. Alright, so question 6 and the dreaded amortization table. Okay. So Ms. Long's saving for a holiday and decides to open a savings account. She plans to add $250 a month to her account. She chooses a bank that has an annual interest or an interest rate of 3.75 per annum, compounding monthly, and she's going to save for 13 months. Alright, so this is the recurrence relation. Yeah. So how much money did Ms. Long deposit into to open the savings account? So it must have been the initial value, $1,000. Alright, so we've got the partially completed amortization table. Balance of investment would have been $1,000 at the start. A obviously was $250. Alright, so now what we know is she's basically multiplying by this amount here and adding $250 each time. Okay, so what we're going to do to work out this value here, we're going to actually use this previous balance and multiply it by this amount here to get this amount. Alright, so we're going to go 1.003125 multiplied by 1761.76. It's not quite what I wanted to do. Let's use this value here, the 3.75. Alright, so plan B, 3.75 over 12 over 100 multiplied by 1761.76. Alright, so this amount here must have been 551. Okay, so 551. Alright, the principal increase. Okay, so what we needed to do is actually add these two numbers together, because this is interest earned, not interest paid. Alright, so a lot of you subtracted 5.51 from 250, but you needed to add it. So that's 255.51. So 255.51. Alright, and then what you're going to do is add this number to this number here to get this value here. Okay, so that would be 1761.76 plus 255.51, 201727. Okay, we did accept 26 as a correct answer as well, if you use the unrounded version of that. Okay, so that wasn't a rounding error, we just flat out accepted 2.26. Okay, so just be aware that that was fine. Okay, how much did Ms. Long's investment increase by from the end of the 9th month to the end of the 10th month? Okay, so for this one I think the best way to do it is to run the recurrence relation in your calculator. So there is the initial value, 1.003125 plus 250. So first month, second month, third month, fourth month, fifth month, sixth month, seventh month, 8th month, 9th month, and 10th month. Okay, so let's just leave that on the calculator, and what we needed to do there was go 3567.14, subtract the previous month, which was the 9th month, 0.81. So that's that amount there, subtract that amount there, and it was 260.33. How much money does Ms. Long have in her account at the end of 13 months? So we're probably going to have to go back to our calculator here and put in the initial value again and multiply by that. So first month, second month, third month, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th, 12th, 13th. 4353.04. Could have done that on the calc as well using Financial Solver. Would have got the same answer. Okay. Okay, how much interest did Ms. Long's investment earn in the 13 months? Okay, so this one here wasn't done particularly well. Okay, so what you had to do for this one here is to note that she, the value was 4353.04, and from that we needed to subtract the $1,000 that she invested. But also we needed to also subtract 13 lots of $250, okay, which basically were her payments. We can't classify them as interest, so this includes her payments as well. So that's where most of you fell down on that one. So it was 4353.04 subtract $1,000 plus 13 lots of 250. And the answer to that was 103.04. Alright, so not particularly done, not done particularly well, that one. Alright, so F, by choosing 3 consecutive terms in the sequence generated by the recurrence relation developed to model the amount of money in her account, show that the sequence is neither arithmetic or geometric. So this was actually done quite well by a large portion of you, and some really innovative ways of showing this one here. So what I'm going to do is just grab 3 terms. So you could just get it from the table. back here. Okay, so this, and this, say, or even this, and this. So let's get 1,000, 125313. Forgotten the number already. 125313. And 1507.05. Let's see if I remember this one. 1507.05. I don't trust myself. Yeah, that's it. Alright, cool. Okay, so now what we're going to do to show that it isn't arithmetic, what we're going to do is just show that there's no common difference. Okay, so to do that we're going to do 1253.13 subtract 1000 equals 253.13. Then we're going to do 1507.05, take 1253.13, and that won't be the same. 1507.05 take away 1253.13, 253.92. Okay, and a lot of you then wrote a disclaimer statement on that. Not the same common diff, therefore, so not arithmetic. Okay, and then we're going to do the same thing, except we're going to prove that, well, not prove, but show that it isn't geometric. Okay, so 1253.13 divided by 1000. And we're going to do 1507.05 divided by 1253.13. Alright, and this will give us the common ratio of both of them. 1253.13 over 1.253. And let's do the next one, 1507.05 divided by 1253.13 equals 1.202. And again, a statement, not the same ratio, therefore not geometric. Okay, so yeah, it was done quite well, so well done on that, girls. Alright, so what we got here in question 7, Mr. Birchick has received a tip from a friend in the business world that a particular share is about to increase. So basically what he's going to do, he hasn't got the money to invest, so this is a common thing to do in the business world actually, is you borrow the money, take out an interest-only loan, and then the investment goes up, and what you do is you sell, and the difference is your profit. Okay, so what we're going to do is calculate the monthly payment correct to the nearest cent. Okay, so if he's borrowing $75,000, what we're going to do is charge the interest to that loan, or work out how much interest he's going to pay, and that's basically what he's going to have to pay, and then he'll get the loan back down to 75 grand. Okay, so here's the calculation. Many of you did this on Financial Solver. That's good. I don't use Financial Solver for interest-only ones, but you can if you want. So we're going to do 9.25% of $75,000, and that means that his monthly payments, that's way too much, compounding monthly. Okay, so I fell for it. So 9.25 over 0.25 over 12 over 100 multiplied by $75,000 is $578.13. Okay, so yeah, don't be like me there. Be careful with that one there. You got to split the interest rate there. But if you're good enough to know that no one's going to be able to pay $7,000 back per month, well, not no one, but that's a lot of money per month. Once you start to get an idea of magnitude of number, you tend to be able to make some mistakes and then go, what did I do wrong there? Alright, so this one wasn't done well either. A lot of you struggled to show that this, the profit he makes overall on the sale of the shares is going to be that amount there. Alright, so the way you do this one here is we're going to say that it's $97,000, okay, and we're going to subtract the original amount that we borrowed, which was $75,000, plus we're going to do, so how long has he got it for? He's got it for 3 years, okay? So 3 years is 3 lots of 12 is 36 payments of 578.13, okay? Alright, so let's see if he's come out at 1,187.32 on that. So we're going to do 97,000, take away 70 grand, or 75 grand, plus 36 lots of, I don't need the brackets there, 36 times 578.13. Well, bang, there it is. Alright, so 1187.32. Alright, now he's also thinks there's a fortune to be made from another investment. Can access an interest-only loan at 9.5% per annum, compounding monthly. Knows that he can afford a maximum monthly payment of $6,500. So how much money should he apply for to the nearest $1,000? Okay, so what we're going to do is do 9.5 on 12 on 100 of an amount, and that amount needs to have an interest of an interest amount of $650. So reach for your calculator and run that through solve. 9.5 over 12 over 100 multiplied by an unknown number equals 650, x. Alright, and that's saying that he could apply for exactly x equals 82105.26. This is to the nearest $1,000. Okay, so thousands are in this column here, rather this column here, that's the hundreds column. So yep, good math teacher there. And so what I would do is he should apply for $82,000 to the nearest 1,000. Alright, so then question D, what's the effective interest rate? Okay, a lot of you went to the formula for this one, but if you just ask for the effective interest rate given the interest rate, make sure you use the calculator one, which is EFF. Okay, so let's go menu, and I think it's in finance. Oops, there it is. What is it? Interest conversion and effective interest rates, EFF. Okay, so we go 9.5 and 12. Tells us that it is to 3 decimal places, 9.925%. Okay, now if you sort of forget which way it goes around, don't bother looking up your notes, just try it out. Okay, so if you put it around the other way, 12 and 9.5, you get an answer of 12.66. Okay, and no way is an interest rate of 9.5 ever going to have be effectively 12.66. Okay, you could compound a million times a second, and I doubt that that's going to be the effective interest rate. Okay, well, not I doubt, it won't. Okay, so that'll just tell you which way to put it around. Okay, is to think that the effective interest rate is going to be a smidge more than that. Alright, so Mr. Greg and Mr. Burchick are chatting over lunch about their finances, and Mr. Greg is recently retired and is wondering what to do with his super. He could invest it in an annuity paying 5.6 per annum compounding monthly. How much would he receive per month if the annuity is for 20 years? Alright, so we're in the financial solver section of the assessment task now. So let's go to finance and financial solver. Okay, so the annuity is for 20 years, so 20 by 12. The interest rate is 5.6. the present value is he is going to give $580,000 to the bank to invest. Payments is the annuity is what we're looking for, and annuities, basically the way they work is we keep taking money out of it until the value of it is 0. 12 and 12, and this will give us our payments. So he could go 4022.58 per month, which is a pretty good living, depending on what your expenses are. Now, he believes that got expensive tastes and thinks he needs $4,500 to enjoy it, so it's not enough. So what percentage is this of this? Again, not done particularly well, given that a lot of you got that first question right. So all it is a basic 1% expressed of another, 4022.58 over 4500 multiplied by 100, and it is 89% to the nearest percent. Okay, so he's almost there. Okay, it's 89% of what he needs. If he would like to receive $4,500 per month, how many fewer payments would he receive from the annuity, including his final payment, which will be less than $4,500? Okay, all right. So what we're going to do here is we know that the original one ran for 20 years. Okay. All right. So what we're going to do is compare that to the annuity that would give him more. Okay. So it's going to be 20 lots of 12 take away the annuity, okay, or the number in the annuity if the payments are 4,500. So let's dive back into Financial Solver. Okay, and what we're going to do, this is the unknown. Okay, now we know what the payments are, which is 4,500. Okay, and what we're going to do is work out the end value, which is 197. Now, that little thing there, which will be less than 4,500, means that we're going to do this 0.6 of a payment. So this is going to be 0.6 of one of these. Okay, so that means it's actually going to be 198 payments, not 197.6 or 197. Okay, so that was an important one there and cost many students a rounding error as well. Okay, so we're going to do 20 by 12, which was 240, take away 198, which was 42. Okay, another option is to invest his money in an annuity company that claimed to give that amount for 20 years. For it, what would be the annual rate to give this return? Again, classic Financial Solver. So this is your bog standard Financial Solver problem. So let's go back to 20 lots of 12. We don't know the interest rate, but we do know that they're offering 4822, and we're after the interest rate, which to 2 decimal places is 7.92%. Alright, question 9. So Mr. Gregg is worried about Mr. Birchick's crazy interest-only schemes and recommends he should invest in property. So what he does, he drops $450,000 on an apartment with interest rates at 4.3% per annum. Term of the loan is 30 years. So again, this is just your standard Financial Solver problem. So no way you're doing this with recurrence relations. Okay, so we've got 30 lots of 12 with an interest rate of 4.3% per annum. He is borrowing $450,000, so the bank gives him, that's positive. And we're after the payments, and what he's going to do is pay back the full loans. So the future value will be 0, and the payments are going to be $2,226.92. How much does Mr. Birchick's fourth payment reduce the balance of the loan by? Alright, so this is a bit of a tricky one. Okay, so what we're going to do is, if these are the payments, let's round this down to 92. Okay, because he can't pay 1/100%. He can only pay 1/10 or you can pay a tenth, a hundredth, you can't pay 1,000th of a cent. Okay, so we're going to round that down to 2 decimal places. All right. Now what we're going to do is we're going to work out the value of the loan, okay, after 3 iterations. Okay, so the third one. So let's look at the future value there, which is 448,150.13. That's after 3. Okay, so we've done this 3 times. Alright, now what we're going to do is do it a 4th time, or work out what the value of the loan is after 4. And there it is there. It's 448,150.13. Okay, and now what we're going to do is basically, what happened there? That's wrong. For future value. Sorry, I thought that number looked familiar. 44759.08. Alright, we're going to subtract this amount here from this amount here, and that'll be the loan reduction. Okay, so let's get out of Financial Solver, back into main screen. 44759.08, and we're removing that from 448,150.13. And that's way too much. I've missed a number somewhere. 447. Alright, I'm going to pause this for a second and see what the number is that I've missed. Okay, so problem solved. I missed a 2 when I was writing this out. Alright, so let's try that subtraction again, and we should get something a little bit more reasonable. So we're going to go up, copy that down. 4529, and there it is. That sounds more reasonable. $621.05. Okay. Alright, a lot of people wrote really large, crazy numbers there, okay, and that's after they got this question right as well, okay, and you know that that's the maximum possible that the payment could reduce the loan by, so it's always going to have to be less than that amount there, okay, so that's when I got that ridiculous answer first. I knew that that couldn't be the answer, because how can you reduce it more than a payment that you've made? Okay, it doesn't make sense. Alright, this one here, after 7 years of the loan, interest rates were increased by 0.8. What's the new monthly interest rate as a percentage? Right, so it was originally 4.3% per annum. They jumped by 0.8, so that's 5.1% per annum. That got you half a mark there, and then what you needed to do was split the 5.1 by 12, so that's 0.425%. Okay, so that was the answer to that. How much money does Mr. Birchick still owe after 7 years? That is, before the interest rate increase. Alright, so what we're going to do is jump back into Financial Solver, and 7 years is 7 lots of 12 payments at this rate here. And that means that he'll still owe 389,000, I keep missing this extra digit here, 04.14. Okay, now those of you who used an unrounded payment here would have got, I think, 0.99 from memory. Again, we accepted that, so if you used an unrounded payment, we gave you full marks for that and didn't deduct a rounding error. In order for Mr. Birchick to repay his loan within the same time frame, what will be his new repayment following the interest the rate increase? Okay, so what we're going to do now is he still owes this amount here, so what we're going to do is round this amount to that. Okay, so that's how much he owes, and we're going to shift it to the present value, 389,000 904.14. Okay, now the future value now is 0. Okay, and he's made 84 payments. Now what's left? 7 years of a 30-year loan. So he's got 23 years and a rate of 5.1. Okay, and what we're going to see now is what the new payments will have to be. Now because there's been a rate increase, that means that payments must increase as well. So it's going to be marginally more, or a bit more than that. Okay, and sure enough, it is a little bit more than that, 2402.31 as an answer to that. Okay. Alrighty. Now, Mr. Burchett cannot afford the new monthly repayment, so he negotiates with the bank to continue to pay the original repayment, but he extends the term of his loan. So how much longer will the loan now run? Okay. So he's basically saying can't do that. Okay, so I'm going to go back to the original repayment, which was this one here. So let's put that back in as his payments. Negative 2226.92. What we're going to do is that's how much he owes, and we're going to see how long this is going to take him. Alright, so because there was nothing really said about the last payment, okay, it could either, you could have interpreted this as 321 with a larger last payment, or 322 with a smaller one. We accepted either 321 or 322. Okay. Now, what you needed to do then was that's how much that section was going to be compared to what it would be on the higher payments, which was 272. Okay, so what you needed to do was do 322 take away 272, take away 272, hang on a sec. My bad there, that wasn't 272, it was 276. That should be 276. Okay, and so let's try that subtraction again. 276, which means that it was either, so we equals 46, but we accepted 45 as well. Okay, so either or was fine. Okay, nearly there. Okay, so we've got question 10. Mr. Miller currently has this amount in a super fund. He contributes monthly repayments or monthly payments of $800. Account earns that, compounding monthly, and working for another 15 years, plans to retire at the ripe old age of 55. Okay, so let's run this through Financial Solver. Okay, so we've got 15 years of payments at an interest rate of 4.1. The present value, okay, and I'm giving that to the superannuation fund. Okay, so that's a negative amount, 350 grand, and I'm paying, or I'm giving, an extra amount there, and 12 and 12. Okay, so this will tell us how much I'm going to get. Okay, what have I done wrong there? Because that's too small. 184. I forgot a 0. That's what I did. Future value. Okay, there it is. I'd be hoping I'd have a bit more than that. So 109,3304.60. Commas in. That's $1 million, and that's pretty standard actually for superannuation. Alright, so I'll still owe 180 grand on a home loan, so what I'm going to do is when I get my superannuation, I'm going to knock 180,000 off that amount there. Okay, so what I'm going to do is, to answer B, I'm going to go to Financial Solver, and I've got 109,000 93304.60, subtract 180,250, and what I have to invest now is $91,354.60. Alright, how much money each month would Mr. Miller receive from both options? And here is option 1 that I can invest with, and here's option 2. Okay, let's work out option 2 quickly because I can do that in the main screen. Interest rate of 4.5% per annum, compounding monthly, lasting forever. 4.5 over 12 over 100 multiplied by 913,054.60 times 4.5 over 12 over 100, and that will give me 342395 in perpetuity, that is forever. Okay, this one here, interest rate of 2.8% per annum, compounding monthly for 25 years. I'd go financial solver on this one. Okay, so we've got 25 lots of 12 at 4.5% per annum. I'm handing over an investment of 913,054.60, so I'm giving that to the bank. I'm interested in the payments, and it is an annuity. Okay, so basically I'm going to be pulling money out of it, and it's going to last for 25 years. So my payments will be, that seems too high as well. Let's see, 913,054.6 at 2.8. I've written the wrong interest rating. Okay, and that was 4235.43. Okay, so 1 mark for that, 1 mark for that. So which one's the better option? Okay, and so a lot of you did a quick calculation on that and thought, well, if I'm 55 and I have an annuity that lasts for 25 years, and that's going to get me to 80. Okay, and if I live to 90, it means that basically I'm going to have no money for the last 15 years of my life. This is not good. Okay, so what you needed to say in writing there is basically use this mathematics to support your answer. Okay, so you got 1 for the mathematics, and 2 then for saying that option 2 would be better because it's in perpetuity. And the other great thing about this perpetuity is this, when I die at 95, this amount here will still be available. Okay, and I bet my kids are going to be pretty sort of happy when they hear that they've got $913,054.60 of their old man's money. Okay, so even if I am hanging around till 95, they got a nice little bit of money coming to them. Okay, so that's how you would justify option 2. Okay, that it's in perpetuity, it's going to last me to 95. Even though this pays a little bit more money, well, a fair bit more, $700 a month, I'm going to stick with this one here that gives me a little bit less, but it does it forever. Alright, the very last question. Okay, so Ms. Hayes loves drinking coffee, and she bought this machine here. Cost her that amount, and she unfortunately doesn't have the money. Okay, so the bank offers her that amount at an interest rate of 12% per annum, compounding monthly. We've got these payments of 178, and we're after the monthly rate. Well, if it's 12% per annum, let's split it 12 ways, means the monthly rate is 1%. Right, at the end of the 6th month, the balance of Ms. Hayes' loan is nothing. Okay, she's paid it off. What's the final payment? Not done particularly well. Do final payment questions absolutely in Financial Solver. Okay, so how long does the loan last for? It is 6 months, I think, from memory. Is it 6? At the end of the 6th month, yes. Okay, now she's getting slugged a rate of 12% per annum, compounding monthly. The bank gives her $1,032. Okay, so that's positive. Her payments are $178. And what we're going to, oh gosh, 178. Okay, and the future value. Right, so what this will tell us is what has happened here. Number of payments is 6, interest is 12, present, future value I didn't reset. Okay, so you've got a classic case here of me not being able to work out the answer to my own question, but you've got to be good enough to know that you're wrong. Alright, so what have I done here? I've tracked back here and thought, okay, number of payments is 6, interest is 12, the present value of my loan is 1,032. What are my payments? Why isn't this giving us a future value of 0? Why isn't it all working out? Well, the reason is when I make payments, I give them to the bank. It's a negative amount. Okay, so what we're going to do now is work out the future value of the loan. Now this looks a bit better. Okay, and basically what this says is that at the end of the loan, this is a negative amount here, which means that I need to give the bank another 43 cents. Okay, which basically means that the 178 is not going to terminate the loan. I need to have or give the bank another $0.43 for that last payment. Now what's the last payment going to be? It's going to be $178 plus another 43 cents, so $178.43. Okay, so yeah, not many of you got that one right. That's the final payment questions are very, very tricky, notorious. So you need to understand and interpret what these mean. Okay, these lines here. Alright, let's go to C. How much interest in total, correct to the nearest cent, does Ms. Hayes pay on her loan? Okay, so what she's going to do is she's going to have 5 payments of $178 plus 1 payment of $178.43. Okay, and what we're going to do is they're her payments. We're going to subtract what she borrowed, and what's left will be her interest. Okay, so we've got 5 lots of 178, her payments, plus 178.43, take away 1032, 1032, and we've got the amount of interest there, which is $36.43. Okay, not many students got that one right either. Alright, the Barista Express decreases in value by 30 cents per use. She uses the machine on average 30 times a week. What will be the value of the Barista Express in 6 months' time? Well, 6 months is 26 weeks. Okay, so we've got 26 weeks where she uses the Barista 30 times, and every time you use it, it deducts by 30 cents. Okay, now it was worth $1,032, so we're going to remove this amount from it. 1032, take away 26 lots of 30 by 0.3 means this machine is going to be worth $798 in 6 months' time. So there it is. Okay,